Welcome. Today we'll see the instantiation of a video conferencing application, Network Slice, driven by an intent-driven, closed-loop platform. The use case is an intent-based video conference service on a network slice with closed-loop resource control. We will show how this use case can be executed using Symphonica. The scope is an intent-based video conferencing service over a 5G mobile network that is aligned to a QoS and price-sensitive enterprise that will be a $1 per hour video conference room based on a service SLA that will guarantee bandwidth and quality. This use case describes the lifecycle management of a video conference service intent offering using a 5G network slice for communication. We will show the edge equipment, a Wi-Fi access point, the video conference and streaming platform provisioning, and slice resource control based on a closed-loop platform. The actors, or components, will be the edge equipment that enables slice access that serves in-venue customers, the video conference streaming platform used to obtain and send video from and to participants using these configured slices, and the closed-loop platform to receive and get resource usage and execute provisioning actions based on KPI analysis to adjust or decrease infrastructure or slice configuration. The catalog we'll be working on is based on a CFS for the Nest, a CFS for the Edge service, and a CFS for the video streaming service with RFS. So for each part of the slice, the RAN, the core, and the transport, and for the Edge service, we'll have the 5G and Wi-Fi portions. Keep in mind that this is an access point. For the video conference and streaming platform, we will have the VSP. For the resources, we will have the resources belonging to a 5G network, the resources that need to be provisioned to connect this edge router to the 5G network and the Wi-Fi, and finally, we have the video conference streaming device that we will provision. In the architecture for this scenario, we have Symphonica in the middle, orchestrating everything and receiving the translation of the intent from the north and configuring the slices. The slices are in the RAN, TN, and core part of the 5G network. We configure the infrastructure where the video conference will run, and we configure the edge controller. When it makes a change in the network, it will send a trouble ticket to Jira, for example. If we look closely at the closed-loop engine, we see that Symphonica will provision the slices, the infrastructure, and the video conference service. Telegraph will collect the metrics. The video conference service will use Jitsi, and the metrics will be sent to the influx database to be analyzed by capacitor. When the metric exceeds or falls below the threshold, an action will be triggered in Symphonica, sending a workflow to increase or decrease slice characteristics. When we send this workflow to Symphonica, Symphonica will execute provisioning changes in the mobile network slice and the infrastructure manager. The KPI that we're going to analyze is the number of rooms that are created in Jitsi. Now we are going to execute the demonstration. Here we have Symphonica, and we can see that the customer has no service. So using Postman, we'll send a 641 compatible service order to create infrastructure. First, we'll send the login service order. Then we'll get the token and send the infrastructure creation for this customer. Now we can check that the infrastructure is being provisioned. Symphonica is now provisioning all the 5G network slicing components, the RAN, core, and transport. When everything is complete, we can set up the edge service creation. So now we wait for Symphonica to finish with the infrastructure creation. Transactions being made there can be seen in the Symphonica executive dashboard, where we have the service order, the inventory, the number of CFSs that are created in Symphonica, the order types, the time it takes to complete each order type, the room orders, and the time they take to be completed. Once we refresh the page, we see everything there. So now the infrastructure is completed. We can go to the inventory and see that the Nest is created. We have the characteristics and the video streaming service created there, and it's linked to the CFS that represents the Nest. Now that the infrastructure is ready, we'll provision the edge service. We can check the flow execution in real time. Here we have the mobile, the Wi-Fi management, and the internal inventory portions. So when it's finished, we can come back here and see that the inventory is complete for the 5G network slicing CFS, the video streaming service or video conferencing service CFS, and the edge service CFS. We can see the service orders that are completed. Let's see now how the closed loop works. Here we can find the closed loop control for video conferencing. There are no active rooms and no closed loop actions because there are no rooms open. We can set alert rules to control the number of active rooms in Jitsi, and depending on this number, we'll be sending our workflow order to Symphonica to increase or decrease resources in the slice and infrastructure. Here is a way to view past alerts. Now we are going to execute new ones. Let's open the first conference room. We'll open the first room. This is me in the Jitsi conference room. Let's wait for the dashboard to show the first conference. Now there's one, and in the back end we're looking at the closed loop log file, and we expect to see the workflow order that the closed loop engine will send to Symphonica. We will open the second conference room using an internal IP address. We now have two. And then we open the last one. We now have three conference rooms, and with the three conference rooms, we expect the closed loop to send the elastic action to increase resources to Symphonica. The action turns critical and triggers a workflow order to Symphonica. The workflow order associated with that customer can be checked in Symphonica. We have two workflow orders, one for changing the closed loop slice. We have increased resources. So Symphonica increased slice configuration based on traffic. The other order was executed in the virtual infrastructure using a virtual infrastructure manager to increase resources in the virtual infrastructure where Jitsi runs. In the Symphonica monitor, we have the workflow order that Symphonica received. We have the current inventory representing the Nest, the video streaming, and the Edge service, and all the information related to the order types, and the time when Symphonica configured everything in the network. If we go to chronograph, we can see that history and the alarm triggered. We have three conference rooms and we'll start closing them, so we expect to receive the decreased resource action when the closed loop platform detects that the rooms were closed. We close one, then two, and the last one. So we wait for that to happen. We have the decreased resource. The number drops to 0 because everything is closed. We have the alert message that the control conference rooms went from critical to OK, and we have the decrease here. If we check Symphonica, we have two new workflow orders. One to change the slice resources, and the other to decrease infrastructure to where the video conference service runs. So in this demo, we showed how we manage a video service over a 5G network slicing that can assure quality through an SLA based on intent-based action. Thank you very much for watching, and we look forward to hearing from you soon.